Hello, I'm making a game using my own game engine, and so far I've managed to create something that is technically a game. Icosahedron's idea is a physics-based game where you roll around on a tiny planet, grow increasingly powerful, and try to survive absurd hordes of enemies. The problem is, it doesn't really look like I wanted to. Right now, our player is essentially a flat, emotionless sphere surrounded by other flat, boring geometry. The mechanics are starting to develop some personality, but visually, the game has almost none. We need some Zaza. The biggest visual problem right now is the planet itself, a perfectly round, subdivided icosphere. Some of you suggested that procedural generation might be in order, and I absolutely agree. The topology of the planet is basically begging for it. Instead of a perfect sphere, I want something a little more irregular, something closer to an asteroid. So I made a small, goofy helper tool inside my engine that generates planets using Voronoi noise. It has a few basic sliders, and for now that's really all I need. I'm not trying to generate the final planet yet. I want to force the game to work on something that isn't perfect. Ideally, procedural generation will eventually make every run feel a little different, not just visually, but in gameplay elements too. This alone, however, seemed like a pretty innocent change. I made the sphere slightly less spherical. What could possibly go wrong? Well, I've just broken the AI of every single enemy in the game, and I need to rewrite the player controller. The old enemy logic relied on one very convenient assumption, that the planet is round. Gravity pointed toward the center, movement was tangent to a perfect mathematical sphere, and to chase the player, enemies could simply project their movement onto that sphere. But our new planet isn't really a sphere anymore. The important direction is now the local surface normal. Every enemy needs to understand the ground directly underneath it instead of reasoning about the planet as a whole. That means every enemy has to start thinking locally. Instead of asking where is the player relative to the center, it needs to ask where is the ground here, which direction can I roll, and how do I get to the player without turning this into Dark Souls. Now, there is an obvious, accurate solution: actually collide every enemy against the planet mesh. There's also an obvious problem: I want my game to have more than 5 enemies. Performing thousands of complicated mesh collision queries every frame would be less than ideal. So, instead, forget everything about accuracy. We're going to do a thing called eyeballing. Our planet has one weakness. I created it. And I don't mean it in a bad way. I mean that I know exactly how it was generated. I don't actually need to ask the mesh where the ground is because I already have the function that created it. So, for any direction from the center of the planet, I can sample that same function and get an approximation of how far away the surface should be. Do this a few more times around the enemy, and I can also estimate the local surface normal, basically which direction the ground underneath is facing. From here, I project the enemy's movement onto that surface. And that's pretty much it. No actual mesh collision. The enemies are essentially just guessing where the planet is. It's another approximation, but for now it feels surprisingly good. And most importantly, it's dirt cheap, which means I can still continue dreaming of creating a game with an abysmal enemy count. Eventually, the player and probably some more important enemies will need proper mesh collision, but that's a problem for future me. Good luck, me! Speaking of collisions, so far we've been mostly concerned with keeping things attached to the planet. But collisions can also give us something much more interesting, things to climb on. One of you suggested creating a parkour course, and I thought, what a great idea! Until now, my collision system was limited to spheres, so I started working on support for more traditional colliders. I also took this opportunity to replace my custom collision backend with Jolt. I'm not using it to simulate the game's physics, the weird physics are still mine, but it gives me a much better foundation for supporting different collider shapes. Getting everything hooked up proved to be less pleasant than I expected, but eventually I had static box colliders working, and for the first time I could actually rise above the surface of the planet. So naturally, I built a highly sophisticated parkour course, consisting of 4 boxes. At the top of the last pillar, I placed something a little more interesting, an icosahedron stellation, also suggested by one of you. Stellations are actually a fascinating topic in their own right, and I'll be making a separate video about them soon. I never considered myself a math guy. We will see how that goes. Anyway, the planet is finally starting to have some shape, but it still doesn't really have an atmosphere, literally. One of you suggested adding fog, and this finally gave me a good excuse to implement something I wanted in the engine for a long time: post-processing. Post-processing is very interesting because it happens after the scene has been fully rendered. Instead of drawing more geometry into the world, we take the finished image and run another shader over it. At this point, we're working in screen space. For every pixel, I can ask, what color is already here? Where is this in the world? And then, what horrible color I can change it into? By the time the shader runs, I already have two useful pieces of information: the rendered image and the depth buffer. The image tells me what the pixel looks like. The depth buffer tells me how far away it is from the camera. Using that depth, together with the camera's matrices, I can reconstruct where that pixel actually exists in the world. And because our world is a tiny planet, its distance from the planet center gives me something extremely useful: altitude. Now I can control the fog based not only on how far something is from the camera, but how deep inside the planet's atmosphere it is. There was one annoying exception: the skybox. The skybox isn't normal geometry. It's effectively infinitely far away, so it doesn't have useful scene depth like the planet does. But obviously, the atmosphere still needs to obscure the sky. Standing on the surface, I want the atmosphere to swallow most of the space, fly away from the planet, and it should gradually disappear. So the sky gets its own calculation, estimating how much atmosphere we're looking through and blending the fog accordingly. And I really like this. For the first time, the planet actually feels like a more closed space. From space. Implementing post-processing also gave me access to something much more fun. Last time, I created this mesh-based corruption effect. It could make an object look unstable, broken, almost like parts of it were being eaten away. But the corruption stopped at that object, and I don't think I want it to work like that. I don't want this object is corrupted. I want the object and the space surrounding it is corrupted. And eventually, the game is corrupted, the controls, the player's powers, maybe even the physics rules themselves. But let's start with the visuals. I already had the final rendered image, and I started treating it less like a rendered frame and more like a picture. Instead of changing the 3D objects directly, I took the image on the screen and deliberately read it from wrong places. Normally, pixels sample the same place from the rendered image. Pixel usually asks, what color am I? But for the corruption, the pixel asks what color is somewhere else. And that small idea is where most of the effect comes from. I divide the screen into stable and unstable regions using layered noise. Some areas remain untouched, some get shifted slightly, and some get pushed harder. The image starts breaking into chunks that no longer line up with one another, which is quite fascinating to look at. I've definitely experienced similar rendering effects before. Accidentally, of course. Creating one deliberately is a very different experience, in a good kind of way. The result has this sharp, digital fractured look. It doesn't feel like a blur or a distortion filter. It feels like pieces of the image are being incorrectly reassembled. And this is something that for the first time while making this game, I would call simply perfect. I've also added the ability to localize the effect around an object, and I must say that I feel like I should be able to create something amazing with this. I am really starting to love this. We have so much more to get through, but that's another time. See ya! Also, please subscribe.